Alrighty. Hey everybody, Jacob Quinn here. Here to talk about some nulls for Julia. Hotly debated issue over years. We could go on and on about everything that's gone on with nulls. I'm here to talk about a new package called Nulls.jl that aims to kind of at least provide a solution that hopefully most of us can get behind, that is simple, that has language support, and works for all cases, most cases. So the problem here is in base we have nullable T, right? We have this nullable type that is a wrapper type. So you give it a type tag, it has space for whatever value is inside of it, and then it also has a Boolean flag saying whether a value is there or not. So the semantics there are you wrap a type in a nullable, and then you can either get it or you can't, and you can check if it's null by checking the Boolean flag, basically. But there's actually a host of problems that come when we try and not only use this for data analysis type workflows, but also just the type itself in general is a bit tricky in terms of getting the semantics right and just having like a sound definition within the type system. Some of the examples, for example, or some of the problems, for example, are this one where when you create an empty nullable, like for an integer, you actually, under the hood, are getting a lot of the times random bits. And the example here for the for loop is I'm just trying to compare two empty nullables a million times, and you can see that I actually run into errors. Like they're not the same objects, even though I said it's an empty nullable int and an empty nullable int. And that's because we get these random bits that have to be initialized underneath, but they're not actually the same bits. So that's one issue that doesn't necessarily, it's not supposed to come up in practice, right? Because you're always supposed to be, using the right methods and saying get and that kind of thing, and just use is equals. But there are a few places, when you get deeper in the internals where this does become a problem, because we do want to check for object equality and that kind of stuff. Here's another issue that is a bit tricky. So how do nullables promote? And here's a case where I'm promoting a nullable 1 with an empty string that's not a nullable, and currently it promotes to nullable any, which is actually pretty poor typing. When you promote an integer and a string, it just promotes to an integer and a string. There is no promotion there, and yet because of these weird, nullable basically is trying to wrap the entire type system here, and so we run into issues where you get these weird results, and it can make trying to work with these in arrays, really, it's just can get weird sometimes mixing types. Here's another, big question that's currently an open issue. Should we allow converting from a nullable T to a T? So this is a case where I have a vector T, vector of integers. I have a nullable int. Should I allow you to just automatically set, do set index on that array with this nullable int? Should it auto unwrap basically? And then if it's null, it would throw an exception. There's just lots of questions around here. Like, should we do auto unwrapping? Should it throw an exception? There's not any other container that kind of allows this auto conversion to a scalar if we are viewing nullable as this, pseudo container type. So it's just, it's tricky. You don't exactly know what to do there. There's also this big, issue around, should we have special syntax for unwrapping, right? So that you can kind of work with nullables without actually having to work with nullables, and we just wrap it all in a macro, and, that's not exactly great, because it's ugly, right? And then in general, there's been lots of debates going back and forth on are nullables containers or not? In some extent they are. It's a 0 or a 1 container. It's empty or it has one element. But that gets really weird when you start thinking about broadcast, and should we do nested broadcast, and should we define filter on it? Should I define an empty get indexed, indexing on a nullable? It just becomes weird, right? Is it an array? Is it a scalar? What is it, right? And then this is also one that kind of touched me a little bit, is it becomes really clunky for this idea of when you want optional keyword arguments, right? So I want a keyword argument for a function. I don't necessarily want to provide a value, right? Like maybe it's, the number of rows you want to fetch, and I don't want to provide one. And so I want to give it default, it'll have a value of null. And yet if I try and use a nullable for that, then the users have to be wrapping everything in nullables all the time, because we can't just like auto convert things back and forth. Anyway, so Nulls.jl, it's great, okay? Because all it's doing is saying, this nullable T can be thought of as union T null, right? So we're relying on the base core language type system to say, a value that you got from somewhere, it's a T or it's null. It's one thing or it's the other. It's not a container, right? It's a scalar. So all of a sudden we actually don't have any of these other problems. We don't have randomly initialized bits that we have to worry about. It's just one value or the other. We don't have to deal with weird promotion issues because it's not a wrapper type. It's not container-like in that you're giving it a type tag, right? The types, the union T null comes from the types themselves, right? Like, inference and the type system are built to handle. There's also no weird, unwrapping, conversion syntax that it's needed, because you're only ever dealing with one value. It's a union, it's a T or it's a null, that's it. And then in terms of like the optional keywords, it actually works really great, because all you have to say is my optional keyword is a union T null, and then the user can pass null, they can pass an int, and it doesn't matter. We don't have to be wrapping anything anywhere. So then why have we not been using this approach all along? Well, first off, there's been performance issues, okay? Union T null, union T S anything, it doesn't have to be null, hasn't always had the performance and optimization focus that it could have. That's being worked on actively right now. There are great branches out there that are fixing these problems. So Jameson actually has a PR up right now where he's fixing an inlining issue where if the return type of a function is a union T null, then it'll actually do method splitting and then inline the results of those. Jameson also has a branch where he's doing an optimization for struct field types that are union, TS, and be able to efficiently in the code gen. That basically boils down to an LLVM select statement, switching between which type gets deserialized out of that field. And then I'm currently working on a branch where we're doing the same kind of optimization for arrays. So there's a long history of data arrays and nullable arrays, and how do we handle missing values in arrays? And the answer is we're just going to do it in the core language itself, using the same optimization techniques for unions in general. So it's not even going to be specific to union T null. It's going to apply to any union of is-bits types in the entire language. And it's really great because you get the most core, like fundamental support that you can get for it, and it becomes super fast. At my talk the other day with data streams, the results that I was showing of getting faster CSV parsing than any other library is largely due to some of these optimizations that we can get. There's also some concerns around inferability, but in terms of the type system, it's pretty well. It's really getting that support to handle union types and being able to be smart about, okay, like I get a union, like I don't know a single type return value from this function, but I know it's a limited set, and so I can optimize the code path where we say, well, depending on the type I get out, I can easily switch code paths in terms of where we go next. There's some issues around covariance, but tuples are already set up to handle that, and so they can infer if one element of that tuple is going to be an int or something else, it can infer that and it'll stick it in as a union. TS. There's a named tuple branch out there, which will, we've talked with Jeff about also having those be covariant. And then there's also this idea of having, arbitrary immutables be covariant. If you have an immutable where each field has a type parameter, that is free and that can be set, that's a great case where you can basically treat that struct as a tuple and be able to infer the fields as union T null instead of struct 1 with a T and struct 2 with a null. And then in terms of container covariance, that's actually an easier problem to solve because you can almost always pre-declare. So that's how I deal with it in data streams. I can just say up front, hey, this vector is going to be a vector T null, and then we can just fill it in and be on our way. So that's another way that we can kind of avoid some of those issues. So the Nulls package is out there. It's got a release for 0.6. A lot of the language support, like I mentioned, is on current branches in master, so that'll be dropping soon. But in terms of some of the semantics here, it tries to be very simple and very straightforward. Now, we are making a few design decisions, and most of those are based off of kind of the Julia language itself. So, in terms of promotion, it's kind of what you would expect. But in terms of like ordering and equality, Julia doesn't have a concept of truthy values or falsy values, right? And so we can't necessarily return a null from an equality, operator. That kind of breaks nulls. It makes them basically useless because you can't ever just do a comparison with a null. You always have to be doing this unwrapping kind of stuff, 3-valued logic, and it gets really messy. So yes, this is a design decision that can potentially lead to, to some subtleties that are different from the subtleties of, wrapping things in nullables, but it's somewhat based on the language, and I think, we'll be able to deal with that. Anyway, so I kind of talked about the timeline, so thanks. That's all I got.